Good morning, ma'am. I am Omkar and Shankpal from a section called IO2A. Now, I am here to explain the topic called FCFS scheduling design and evaluating that FCFS. First, let us know the the full form of FCFS. The abbreviation of it is first come first serve scheduling. And now I am going to explain the introduction of it. In a modern operating systems, many processors compete for the CPU. Since only one processor can execute at a time, CPU scheduling decides which process runs next. Its goals are to reduce waiting time, improve system throughput, and ensure fairness. In this assignment, I selected FCFS, first come first served, which is simplest scheduling algorithm. It is a non-primitive, meaning once a process starts, it will runs until completion. Processes are executed strictly in order of arrival. Next, now I am going to explain the experimental setups. Here I used a C programming language because of its readability and simplicity. I ran this program using C compiler, and I have created the three data sets, each representing different scenarios. First, data set 1 staggered arrival, and data set 2 long first job, and data set 3 user given data set. Here here the arrival time and the burst time is given for the each data set or process. Each data set contains arrival time and burst time that test how FCFS behaves under different load patterns. Now now implementation steps. Here, in this implementation steps, we have to start the program, then we have to begin by including the necessary header file studio.h, and it has defined the proper structure process to store different times. Next, step 2 is the number of process. We have to give an input for the process, and we have to take the input for each process. Then we have to sort process by the arrival time. Here we have to sort the processes but according to the ascending order of arrival time. Then we have to calculate the scheduling parameters. Then we have to display the table, and then we have to calculate the average weight and the average turnaround time of the table. Next, flowchart. This is the flowchart of the topic called FCFS. First, we have to start the program, then input we have input number of the process. We have to take input for arrival time and burst time for each. Then we have to sort the process by arrival time. Then for each process, starting time, complete time, waiting time, and turnaround time, we have to calculate all the times, and we have to display the table. Then we have to calculate the average of the waiting time and turnaround time. Then we have to write a Gantt chart. Then we have to end this process. And this is the code of the implementation steps, or this is the code which we have used for FCFS thing. I'll explain it by running, and I'll show the output, and I'll explain the output afterwards. Then this is the observation. Now I am going to explain the observation. From all data sets, I observed that FCFS works efficiently when processes arrive at different times with small bursts. When long processes come early, shorter ones wait unnecessarily. Then response time and waiting time are the same because FCFS is non-primitive. Performance of FCFS depends heavily on arrival order, not burst time. Processes that arrive later always suffer higher waiting times. CPU utilization is usually good, but delays increase as burst times increases. Next next I'm going to explain the comparative analysis of this thing. Here here data sets use data set 1. There are having three processes. Arrival time is 0 for all that thing, and burst time is 531, and the average of that thing is 4.3 and 9.33. Here the comparative evaluation is done when we are taking a three outputs from the code. Now I'll explain that code and output. And here they have compared three data sets by the arrival time and the bus time and took average of it. And the conclusion from this assignment, I learned how FCFS scheduling works and how arrival order strongly impacts performance. I implemented the algorithm, tested it on three different data sets, and compared average waiting and turnaround times. FCFS is simple and easy to implement, but it is not suitable for real time systems because I cannot handle deadlines. It causes long waits for short processes, and it is non primitive. It suffers from convey effect. It provides no priority or deadline handling. Therefore, FCFS is only suitable for batch systems, for environments where fairness is decided by arrival time but not urgency. This is all. These are all the. These are all. These are all things I have explained about FCFS. Now I'll show the code and the output of it. This is the code of the program. Sorry, this is the code or program of our topic FCFS scheduling design. And when we run this thing, it will ask the number of processes, means how much processes it should contain. We have to enter it. Let us give 3 here. And next, the arrival time of P1, let us give 0. And burst time of P1, and we have to give a burst time of it, let us give 5. And arrival time of P2 is 0. Burst time of P2 is, let us give 5. Here let us give 3. And then arrival time of P3 is 0. And burst time of wait 3 0 5 0, here 3. Burst time, let us give the burst time of P1 is as 7. And when we run this whole thing, here will come ID, means number. Arrival time is 0. Burst time of that processes is 557. And the starting time, its starting time is 0, then 5, and it will become 10. And the complete time is 5, 10 and 17. Waiting time is 0, 5 and 10. Turnaround time is 5, 10, 17. And here the average, we have to calculate the average of this waiting time. So we have to do 0 plus 5 plus 10 divided by 3, then we will get an answer as 5. And average of turnaround time is same as we calculating this average of wait time. Here 5 plus 10 plus 17 by 3, answer will come 10.7. This is all about the code and output. Thank you.